right? That's pretty scary. What does that mean? So how do we deal with ethical issues, legal issues, etc.? Science. How about a web of objects? You know, pretty soon objects are going to be on the web. Not just pages, but people, but devices. And when you look at these kinds of questions, these aren't the questions that the computer scientists can answer. These aren't technical questions. These are more social questions. They require a lot of understanding in a lot of fields. No one can be a single expert in answering those kinds of questions. This is a very famous slide that the Web Science Trust uses, basically talking about, as it were, all the disciplines that could be involved in studying web science. Once again, as I described to you, it's really those disciplines that are affected by the web or affect the web. And so one of the goals of web science is to say, how can we bring these disciplines together to get a firmer understanding? So I would say the biggest problem with this is communication, right? They're all like cells. But what all these cells have difficulty doing is exchanging their DNA, exchanging their relevant information. So, excuse me, when the computer science people talk to the sociology people, and they start throwing around terms like TCP/IP, HTTP, then the sociology people's eyes sort of roll back in their heads and say, what is all this stuff? Okay? So there needs to be some way in which there can be methods of communication. So the goals of web science are to understand, as we said, what the web is, to maybe engineer the web's future, and to make sure, and this is a very lofty goal, to make sure that the web continues to have social benefit. I gave this talk one time, and one of the people in the audience says, does that mean that you believe that the web could become the Matrix? Not quite that way. But we do have to still make sure that the web is going to be serving our purposes, because that's why it was created. We didn't create something that we want to turn against us. Now, if you have a science, you have to have engineering. But unfortunately, in this history, the engineering came first. So there is a relationship between web science and what we might perceive as engineering, because we already use that term, engineering. And here's a definition of what web engineering currently is. And if you read through that, once again, its focus is on systematic methodologies. So, to the first order, I think what we're seeing in web engineering right now is more like web project management. We're not really taking our existing knowledge that we might have about the web and actually apply it in a truly engineering way. And two, one would expect that science, web science and web engineering would track one another. So here's Google Trends talking about the interest, showing the interest in web science over the last several years, and where in fact that interest lies. But here's a similar interest in web engineering. It's going down as opposed to web science going up. Now one would ordinarily think if there's a true relationship between web science and web engineering, they should track one another. And I believe they're not, simply because we have a very limited definition about what web engineering is. And one of our challenges, too, then, is to define web engineering in such a way that it reflects what we want to get out of web science. Now, I'll give you an example of that. Here is the first page of an article that was in the Communications of the ACM in March. And this article is entitled Engineering the Web's Third Decade. So I saw that and I thought, man, that's great. It's going to be talking about web science and web engineering. But the interesting thing about this article is that the title is the only place that the word engineering appears. That who wrote this article was basically saying, yeah, we can grab their attention if we say something about engineering. But once we've got their attention, we don't have to follow up on that. Primarily because we don't know at this point about how to apply engineering in the case of the web. So here's a couple of definitions that I like here. If you think about what is science, a better model of what exists in the world and how it works is science. And if the intended result of doing that science can be applied to a new product or process or methodology, then that is engineering. So you heard about the roles of web science, the kinds of questions you want to understand in web science. So once you have those answers, or think you might have those answers, then how do you apply them in an engineering way? Now, part of the problem here is that we still think about engineering, science, the same way we thought about it for 200, 300, 400 years ago. We always still talk about the scientific method. You know, we have models of systems, and we will have to build experiments to test those models, and we have to evaluate results. We have to have hypotheses. Now that might be pretty difficult to do in the case of the web. At least not in the way that we do it with, say, the traditional sciences. So my question in this case is that what would a conjecture of the web look like? And is it truly one that we would expect to see like we have in the scientific method? For example, you would hear people say, every page on the web can be reached by following less than 10 links. That sounds good, but can you prove it? Can anybody come up with a model? Well, maybe you can in that case. Can anybody come up with a model to prove it or disprove it? But you don't know how many pages are on the web. So how do you know? And some of those pages are dark. Or the average number of words per search query is greater than 3. You can look at log data, but can you prove it? Can you come up with a reason about why that's true? So what constitutes a good conjecture? Now you notice I use conjecture rather than theorem. What constitutes a good conjecture with respect to web science? Now, we look here and we say, well now, what's happening to science, in this age of high performance, petabyte level data? How are we doing science? And you can see in a couple of these quotes here is that, well, maybe one thing that you can do is you don't need the models. You don't need the old-fashioned way. Because if you've got enough data, and you throw enough computing power on it, and you throw enough statistical rules, maybe you don't have to have a closed model or a proof.